That's it, switched on. Okay, great. So I gave you a little bit of background this morning on things from the UK's perspective. In the UK, as Aisha, I think, mentioned as well, we have a committee on climate change who set our carbon budgets, and their job is to provide independent advice to government on how to meet those budgets, as well as simply setting them. They decided 2 years ago to have a look at bioenergy. Now, I think we've heard various terms used about bioenergy this morning. Chairman, I think, described it as, was it challenging, complicated, those sorts of things. I prefer to use the word interesting. It's a very varied topic. And the Committee on Climate Change felt that really they needed to take a thorough look at bioenergy and see where it fitted from the UK's energy perspective, because there was such controversy about it. The NGOs get very excited about the amount of pellets which we import for Drax Power Station and whether this is sustainable or not. So what I'm going to do, and I'm going to try and do it very briefly really in these slides coming up, is give you a flavour of what we went through with the committee then. They set this up as a totally independent piece of work, and we had an independent advisory board, and I chaired that advisory board. The advisory board produced its own report separate to the main report. I really recommend that you look up Committee on Climate Change Bioenergy Report and look at the main report. It's really fascinating. It did a huge amount of modelling work, similar to some of what Torius has just shown, looking at cost benefits from a UK perspective, with none of the focus on woodland, a lot of focus on other things. So I'm going to very quickly run through all of that, really as a way of priming for tomorrow. So I'm not going to give any answers here. I'm going to recap the issues which that committee raised last year, which it said, if we're going to do bioenergy and we're going to do it sustainably, these are the things that you as a research sector really need to sort out, okay? So the first thing here is about maximising the potential, and this is about this resource efficiency business. Bioenergy is unique among the renewables because it occupies land. That is reality, we cannot change it. And that gives rise to a whole set of interfaces that the energy sector is just not used to dealing with. We've got those physical interfaces around the land use, the transportation, the moving of material. We've got market interfaces that sit around the stuff we've just been talking about with the paper sector and with others that do not exist if we're sitting in the petrochemical or in the wind energy sector. There are food interfaces. There are transportation systems. And then on top of that, we've got the fact that sustainability isn't just about climate change. We've got ecosystem impacts, we've got socioeconomic impacts. So the first thing the committee did was they said, you know what, we get it. This really is incredibly complex and incredibly complicated. And it's important that we recognise that up front and we don't brush it under the carpet. The next thing that we really struggled with in the UK is the fact that we do have a very, I'll call it a hands-off energy policy. It's very much let the market decide. We've put mechanisms in place in the electricity sector, in the fuels sector. We now have something in place in the heating sector, and we don't really care what fills it. We say, oh, the lowest common energy vector that can make it in there, we'll have that. Bioenergy sets particular challenges around that because you can convert it into so many different vectors. So we have a real big challenge here in terms of, do we convert it to gas? Do we convert it to liquid? Do we produce electricity from it? So the fact that we have multiple products and vectors and we don't know what is optimal was the next big challenge the committee flagged. The third one, I think, is possibly the biggest challenge of all, and it was really inspiring to hear so many of the industrialists this morning say we need to work together, because I think that's the key to this third one, which is that we talk about bioenergy and we talk about supply chains like they were a physical thing in existence. They're not. They're a construct that we have to make by going out into the forest, by gathering stuff, by trying to invent ways of converting it, by creating those markets. None of this is already in place. And within that, you've got a whole set of different people who quite like the world the way it is, who are happy with their forestry sector, unless they get fired, as they have done this morning, who are happy with the forests the way they work, who are happy with the products that they have. Why should they change? Why should they instead be looking at these bioproducts and biomaterials? And each of those individual actors along the chain has their own set of priorities. And one of the classic ones that gets brought up all the time here is landowners. Why should the average farmer, who's perfectly happy with his cows in his fields, suddenly decide to go and do anaerobic digestion? It's not a priority for the individuals. And yet, when we look at the global system and we run fancy models in computers, we come up with the same conclusion all the time, that these things must change. But what we need to do is to align the priorities of all the individual bits along that supply chain to encourage that change to happen. And it's not about a single system where we can pull a trigger and say, hey, I've put a policy lever in place, so biofuels should come through. Because each little bit of the chain has a separate priority and an individual view on the world. So that is the third really, really big challenge that we have with bio. So when we looked at this, we divided things up into the different steps and stages. Production, I've talked about these. I'm simply framing them for tomorrow, really. Land use, massive issue. The climate interface. From a UK perspective, we have very limited supply. And when we look at that, most of it is going to come from the waste material. So we have real challenges there around mobilising the supply chain. But perhaps it can be argued that the international supply chain is an even bigger challenge. And there the issues, I think, are all about transparency and trust. They're not technical. I absolutely get that we can run forest models and we can look at what it is sustainable to remove. And I think that our knowledge is good enough to be able to make a reasonable stance at saying what we can and can't take as an allowable cut in a forest. And I believe that we can actually monitor the impacts that we're having on that. We have the spatial systems, we have the satellite imaging in place. The problem is that people don't trust what we're doing. And that is a huge issue. It's not something that scientists can very easily solve. Yet every time we run these surveys, we find that the public trusts scientists more than they trust anyone else. They don't trust government on this, and they certainly don't trust industry. So I think there is a role for us to be talking a little bit more in very simple terms about what we're doing and how we believe this can actually be sustainable. International supply, waste management. One of the things that's looming here is the circular economy, which people keep talking about and not really doing. And how bio and increased levels of waste through to energy can sit alongside a genuinely circular economy, I think is something that we have yet to bottom out. I'm not entirely convinced that it always makes sense to take some of our organic residues and turn them back into clever products. I think that there is a role for energy here. I think that there is cases where that can actually give us better carbon reductions and better overall sustainabilities. But the database that we have of cases where we actually demonstrate this is very, very sparse. So I think that needs some real work and effort from the academic community. Technology. I'm going to start with the obvious one, the agricultural technology. We actually waste huge amounts of residues when we do our food production, and we waste huge amounts of the forestry residues through non-optimal management of these things. So I think there's a role there. A big challenge that the UK is focused on is biomass to energy with carbon capture and storage. I mentioned this morning that hydrogen is ultimately where we're headed on this, and that is a huge challenge, but I think we need to think about this earlier. When we're looking at liquid biofuels and gaseous fuels, there are also opportunities for carbon capture and storage, and we're not integrating those at the moment into the process schemes that we're designing in the way that we could. Renewable gas is up there, and aviation biofuels. These are all things that still have big technical challenges to improve the conversion efficiency. Something I want to spend a few minutes on, if I can, enhancing the climate benefits. I think it's really important to scientists that we understand the difference between variation and variability. And this is something that, as an editor, I constantly see misused and misappropriated. Variation is where we have a system where we make choices, and the choices will be different, And as we have a different system with different design parameters and different building blocks, we will get a different result. Variability is something quite different. Variability is a natural thing. It's the fact that in one field we may get a different yield to the one we get in the next field. It's something that is essentially beyond our control. And I think it's really important when we look at the analysis that we carry out of bioenergy systems, that we consider both variation, the stuff that we're building in there and we can have control over, but also the natural variability that may occur when we're looking at the error bounds on some of the climate impacts that we're having, which I think at the moment are generally quite poorly characterised. It's really rare to see carbon emission figures that have a plus or minus X% on them, and I think we need to be thinking about that a bit more. Measuring carbon performance. Lots of the mechanisms that are in place now for rewarding renewable fuels require you to carry out some form of carbon performance measurement. And it really frustrates me when scientists think that it's good enough to pick up whatever the legislation says and run that calculation and claim that that is the actual climate benefit. It very rarely is. We need to go back, and it's our responsibility to think about the question that we're framing, to think about the unintended consequences of the system we're creating, to think about what we're displacing, and to say, actually, what is the real impact of this system? Legislation has quite a different purpose. Its purpose is not to reflect the real world. Its purpose is to encourage certain types of behaviour which will improve the world that we live in. That's not quite the same thing. And I think it's really important that we get that and that we don't just slavishly follow whatever RED 2 put in every time we carry out a carbon calculation. If we do that, then we stand a chance of looking at the bottom one and actually enhancing sustainability. So, when the advisory board completed its work for the committee, we made a number of recommendations on the policy front. It seems a total no-brainer that any mechanism that we put in place for biofuels or bioenergy systems should have a minimum performance threshold that has to be better than the fossil fuel. We were split as to whether we felt that that should be significantly different. Often you see targets where people say, oh, we want 60% reduction compared to the fossil fuel equivalent. Actually, with the logic of cumulative emissions that we have around our carbon budgets, any reduction next year is better than a 50% reduction in 20 years' time. So it's really important, I think, to get every atom of carbon dioxide that we can removed as soon as we can. And so I'm all up for any reduction at all that's better than the fossil fuel. And I don't really buy the argument that we might get stuck in technology lock-in. We are so far from the targets that we have to reach that I think the last thing we need to worry about at the moment is lock-in. We said that we were really wanting, therefore, to get the minimum better than the fossil fuel, but also that we recognise trade-offs. Land management is something that we felt was under-focused on, really, from a UK perspective. And we need to look in a much more integrated way at how we're managing the land to provide multiple benefits. So there are climate issues in there, there's afforestation to be done, but as we look at climate adaptation, we also have issues around being resilient to flooding and to other types of extreme weather events in the future, and strategic planting around the bioenergy side can actually help with that. Transparent certification from imports from low-risk areas. This again seems like a no-brainer. I would slightly challenge some of the comments that have been made this morning about not having more imports. I think we should have imports. I think if we look at the reality where we sit at the moment, the energy consumption in the northern hemisphere is massively higher than that in the southern, and yet the southern hemisphere has the vast majority of the bioproducts. I think that there's scope to do that sensibly with a rebalancing around sustainable development goals where we actually empower nations in the global south to produce in a way that can provide global climate benefits. Flexible governance. That sounds like a bit of a misnomer, but I think it's important that we exclude the things that are most detrimental and yet still incentivize best practice. And that may mean that we need to adjust the rules depending on where we are. The example of palm oil has already been brought up this morning, which has some very specific issues because it grows well in such a small part of the world. But that's not necessarily the case where we look at places like the Amazon and where we look at some of the sub-Saharan African regions. So we need to be really careful about thinking that sustainability means inventing rules that we then blindly apply everywhere, because they don't fit everywhere. So the last one, different standards in different regions, but also recognizing institutional capacity. It really, really irritates me when we invent pages and pages of legislation which we think it's a good idea to apply because it gives us really accurate numbers on the material that we're bringing in. But what we're actually doing is we're excluding all those producers who don't have the capacity to be able to keep up with the paperwork, to employ 15 people to crunch the numbers, to produce things that are so uncertain anyway in terms of the actual impact we're having on the planet, that they're not actually as useful as I think we sometimes rate them to be. And therefore, I think we need to really recognize the potential in some producer countries where they have more limited institutional capacity and support them in doing things that are as sustainable as they can be. So I have lots of suggestions there that came through from the committee just over a year ago, and the report was, I did mean to put the location for the report on the slide, which I haven't done. I apologise for that. But I really do recommend that you have a look at it. It started off as a report on bioenergy, and by the end, the title had completely changed, and it was called The Role of Biomass in a Low-Carbon Economy. And that was really to recognise the fact that halfway through they had the realisation that biomass was useful, not because of what it could displace, but because that it's sequestered from atmosphere, and that it's that sequestration balance with what is being sunk that actually gives the climate benefit. And that's really important to remember. Okay, thank you.
Thank you.